Concept videos. Subject Applied Physics. Thermal Radiation. Name Sham Kumar. Roll number C9 219511 C9. Section ITB. Second semester. Thermal Radiation. Thermal radiation is electromagnetic radiation generated by the thermal motion of particles in matter. Thermal radiation is generated when heat from the movement of charges in the material, electrons and protons in common forms of matter is converted to electromagnetic radiation. All matter with a temperature greater than absolute zero emits thermal radiation at room temperature. Most of the emission is infrared IR spectrum 73 to 86. Particles motion result in charge acceleration or dipole oscillation which produces electromagnetic radiation. The peak wavelength and total radiated amount vary with temperature according to Wind's displacement law. Although this shows relatively high temperature, the same relationships hold true for any temperature down to absolute zero. Thermal radiation is the emission of the electromagnetic waves from all matter that has a temperature greater than absolute zero. The thermal radiation reflects the conversion of the thermal energy into electromagnetic energy. Thermal energy is the kinetic energy of random movements of atoms and molecules in matter. All matter with non-zero temperature is composed of particles with kinetic energy. Thus, atoms and molecules are composed of charged particles. Photons and electrons, the kinetic interaction among matter particles result in charge, acceleration and dipole oscillation. Properties. There are four main properties. Thermal radiation emitted by a body at any temperature consists of wide range of frequencies. The frequency distribution is given by Planck's law of black body radiation of idealized emitter as shown in the diagram at top. The dominant frequency or color range of the emitted radiation shifts to higher frequencies as the temperature or the emitter increases. For example, a red hot object radiates many in the long wavelength of the visible band. If it is heated further, it also begins to emit discernible amount of green and blue light, and a spread of frequencies in the entire visible range cause it to appear white to human eyes. It is white not hot. Even at a white hot temperature of 2000 kelvins, 99% of the energy of the radiation still is infrared. This is determined by the Wind's displacement law. In the diagram, the peak value for each curve moves the left, temperature increases. Selected radiant heat flux. The time to damage for a exposure radiative heat is a function of the rate of delivery of the heat. Radiative heat flux and effects 1 W by centimeter 2 is equal to 10 kilowatts by meter square. Kilometer watts by meter square effect 170. Maximum flux measured in a post flashover compartment. Radiating heating and cooling. Radiant heating and cooling is a category of HVAC technologies that exchange heat by both convection and radiation with the environments they are designated to heat or cool. There are many subcategories of radiant heating and cooling, including radiant ceiling panels, embedded surface system, thermally active building system, and infrared heaters. According to some definitions, a technology is only included in the category if radiation comprises more than a technology is only included this category if radiation comprises more than 50% of heat exchange with the environment. Therefore, technologies such as radiators and chilled beams considered heating cooling within the category. It is practical to distinguish between high temperature radiant heating devices emitting source temperature 30 degrees Fahrenheit and radiant heating or cooling with more moderate source temperature. Heating. Radiant heating is a technology for heating indoor and outdoor areas. Heating by radiant energy is observed by every day. The warmth of the sunshine being the most commonly observed example. Radiant heating as a technology is more narrowly defined. It is a method of internationally using the principle of radiant heat to transfer radiant energy from the emitting heat source to an object. Designs with radiant heating are seen as replacements for conventional convection heating as well as way of supplying confined outdoor heating. Thermal radiation process by which energy in the form of electromagnetic radiation is emitted by heated surface in all directions and travels directly to its point of observation at the speed of light. Thermal radiation does not require an intervening medium to carry it. Thermal radiation ranges in wavelength from the longest infrared rays through the visible light spectrum to the shortest ultraviolet rays. Heat radiation is the transfer of internal energy in the form of electromagnetic wave for most bodies on the earth. This radiation lies in the infrared region of the electromagnetic spectrum. Any object emits some amount of electromagnetic radiation of thermal nature, which is called thermal radiation or sometimes heated radiation. This means that some of the thermal energy is converted into electromagnetic radiation energy only at absolute zero temperature, which can never be exactly reached. That thermal radiation would vanish. Interchange of energy. Thermal radiation is one of the three principal mechanisms of heat transfer. It entails the emission of a spectrum of electromagnetic radiation due to an object's temperatures. Other mechanisms are conventional conduction. Laws of thermal radiation. All bodies emit radiation to their surroundings through electromagnetic wave due to the conversion of the internal energy of the body into radiation. Reflectivity, observability, and transmittivity of bodies are different Planck's laws for spectral distribution of emissive power of a black body is represented in set 10.4, which has been said that Stephen Boltzmann equation of total emissive power of a black body. Wind's displacement laws is given in the next section. Concept of gravity, emissivity and observability has been established. Lamb's Coulson law has been presented by utilized to determine intensity of radiation in terms of total emissive power of black body. Kirchhoff's law of radiation. Kirchhoff's law of radiation. All bodies radiated energy in the form of photons. When these photons reach another surface, they may either be observed, reflected, or transmitted. The behavior of a surface with incident radiation is described by the following quantities. In heat transfer, Kirchhoff's law of thermal radiation refers to wavelength specific radiative emission and absorption by a material body in thermodynamic equilibrium, including radiative exchange equilibrium. A perfect black body in the thermodynamics equilibrium absorbs all lights that strikes it and radiates energy according to the unique law of radiative emissive power for temperature T, universal for all perfect black bodies. Kirchhoff's law states that for a body and a aberrative material emitting observing thermal electromagnetic radiation at every wavelength in thermodynamic equilibrium. The ratio of a emissive power to its dimensionless coefficients of observation is equal universe function only of radiative wavelength and temperature. The universe function describes the perfect black body emissive power. Kirchhoff's law has another corollary. The emissivity cannot be exceeded because the frequency cannot conservation of energy, so it is not possible to thermal radiate more energy than black body at equilibrium in negative luminescence. The angle and wavelength integrated absorption exceed the material's emissions. However, such systems are powered by external source and therefore not thermodynamically equilibrium. Thank you.